Alright, final question, which is about piecewise graphs. It says that the graph shows the distance traveled by an object from its starting point. So we've got the graph, we have distance on the y-axis, we've got time on the x-axis, and we've got a few questions to answer. Okay, what's the maximum distance the object was from its starting point? And that's its maximum distance. So 7 meters. Don't forget units. For how many seconds was the object at rest? So at rest means it did not go up or down, it was just at rest, and that is over here. And so we know that's for between 8 and 9 is 2 seconds. Okay, calculate the gradient of, should say, each segment. Okay, so we're going to break this up into different segments. We're going to call it A, B, C, D, and E. So remember when I told you gradient is always rise over run. The rise in our case is 4. So we can see this has gone up 4 meters. And its run is just 1 second. So I can come and say 4 over 1, which is equal to 4. For part B, the rise is 1 meter, but the run is 5. We can leave that just as a fraction even is okay. For C, the rise is, it's gone from 3 to 7. So that's 4 over 1, 2, 3 seconds. So 4 over 3. Because the run goes from 5 till 8. Yeah, 3 seconds. Alright, part D has a 0 gradient, but why? Because its run is 0, its rise is 0, its run, although it's 2 seconds, but we know that's just 0 divided by 2 is 0, because it doesn't have a gradient. Okay, gradient pretty much is slope. So if I've got something that's flat, that's got a slope of nothing, and then as I increase the gradient goes that way, and then if I wanted a negative gradient, it's going down that way. Okay, so really technically this gradient here that we calculated 1 over 5 should be negative 1 over 5. So the gradient of E also going down is going to be negative. The rise is 7 over the run, which is 2. But I would write it as negative 7 over 2 because you are smart enough to see that the gradient is negative. So that's negative gradient. This one's a positive gradient. Okay. So we've done that. Part D, calculate the total distance traveled by the object. Okay, so this object went 4 meters in a certain direction, and then it turned back for 1 meter. So it turned back 1 meter, so that's a total of 5. So 4 plus the 1 is 5. 5 plus another 4, that's 9. So I'll just write 4, 1, 5. Then it doesn't go anywhere. So 0, didn't go anywhere, then came back home or wherever to its starting point, and that took another 7 meters. So the total is 4 plus 1, which is 5 plus 4, not 5 meters there, there's 4 meters that way. So we've got 9 plus 7, 16. So we've got a total of 16 meters. Okay, this one's done. All right, and that's all.